Hello, I'm Lucas Bergeron, and I'm going to be going over what I did for Physics 2212 Lab 3. So the lab objectives were to calculate the magnetic dipole moment using the Biot-Savart law and the property of superposition. Below are the two parts of the Biot-Savart law, which is the magnetic field on axis and perpendicular. And the property of a superposition is very similar to what we did for electric fields, where you find the overall field by adding the two fields at a point from two different objects. So for this lab, we used the objects we used for superposition was the Earth and then the bar magnet that we were given. So setting up the lab, we aligned the magnetometer with Earth's true magnetic north-south axis. So you aligned your phone, or I aligned my phone, where the Bx is equal to 0 t without the magnet, and the magnet was measured perpendicular to the y-axis. And then we also found the location of the magnetometer on our phone by crossing tape. I took it off, but it was like tape. Tape was crossed just to show where it was. So with my calculations, this is what, with my measurements, this is what I got. So as you get further away from the magnet, as you can see right here, as distance is as distance is increasing, then our magnetic field is decreasing, which makes sense because we know that magnetic fields decrease with distance, same as electric fields. So here is the slope of this of that difference, and then we'll use both the slope and the y-intercept in our calculations for the dipole moment later. So we calculated the dipole moment. So we used a formula that ln b of x is equal to ln of k plus n times ln of r. So ln of r and ln of bx are changed right here. N and k are constants. So we use ln of k is equal to our slope from before, which was negative 14.34. No, sorry, our intercept from before, which was negative 14.349. N was equal to negative 2.8587, which was our slope. And then we said k is equal to, we take the ln of both sides to get k is equal to this. And then we're using the formula from before. We were able to calculate that mu is equal to 2.935 a times m squared. So we then do more calculations using the rest of the Excel spreadsheet. So we found the distance of the finding the perpendicular distance of the magnet. We were able to find the magnitude of that just by using the distance or the square root of d squared plus d squared, and then we were able to find B net right here, or we were able to calculate B net, which was 2.26 times 10 to the negative 5 t's, using the average of the three different models that we had. But then, however, the code, using the basis of the code that we were given in the lab assignment, I was able to create a glow script code to calculate the B for it, and it was 7.59 times 10 to the negative 6, which is pretty different from what I actually solved, which stands to reason, just because there are, especially for a lab like this, there are many different ways that you could have error. So the Earth's axis might not have been aligned properly. This is just an app that I'm using on my phone for the magnetometer, and I'm not sure how precise the magnetometer on my phone is. So a more precise magnetometer would have a much different reading. And also the biggest issue is just interference from different electrical devices. I did this in my dorm room, which even as far away as I can get from anything, there's still going to be so many different sources of interference, like the wires in the wall, the TV, speakers. It's very difficult to go to a place where there is no interference. So that would be the biggest cause of any such interference. And then theoreticals are, what if we did not orient with the magnetic north or south at the beginning? So that means that Bx would not equal to 0 t, and we would have to correct for the x component as well as the y component. And also, what if we use two magnets stuck together, It wouldn't change the direction of the field, but it would increase the magnitude because they would be aligned in the same direction. So yeah, direction will not change, but magnitude would increase. And that's all for lab 3.